Morning children. So welcome back to the online session of a physics class. We are discussing about the lesson motion. In that last class we have discussed about solving a problem, that is finding out the acceleration for the real time situations. So there will be situations there we need to find out the acceleration. So how to find out the acceleration? So we have learned by taking the initial velocity and then we are taking the final velocity, then particular time, what is the time taken. So using these three quantities we can able to find out the acceleration. So we have the acceleration formula, that is a is equal to v minus u by t. So where v is final velocity and u is initial velocity and t is time taken. So using these values I can able to find out the acceleration. And very important, acceleration, it has to be the unit, it has to be meter per second square. So if the velocity is given in kilometer per hour, then it has to convert into meter per second only, because the acceleration should be there in meter per second square only. So acceleration we can't able to write in terms of kilometer per second square. It has to be there in meter per second square only. So whatever the quantity, whether it is a time quantity or whether it is a velocity, it has to be converted into a meter and then a second. Then we should substitute in the acceleration formula. Okay. So I have given the homework of this question, but nobody has sent it to me. I don't know what difficulty in this question for finding the acceleration. The same type of question I have done it. The second question is almost the same type of question. So it's very easy. Third question is a train starting from a railway station. If anyone done that, please cross verify that. Okay. So a train starting from a railway station and moving with a uniform acceleration at a speed of 40 km per hour in 10 minutes. Find its acceleration. So if you want to find out the acceleration, so you need to find out the final value of the velocity, initial value of the velocity, then the time taken. You need the final value of the velocity, you need the initial value of the velocity, then you need the time taken. If these three quantities you have, then you can easily find out the acceleration. Correct? Okay. So in the particular situation, what is the initial velocity? A train starting from a railway station, it will be starting from a railway station. Then what is the initial velocity? That means it is starting from a stationary position. It is starting from a stationary position because it is starting from a railway station. That means stationary position. It is standing. That means starting from the stationary position. This is what is initial velocity? Initial velocity is 0 because it is starting from the stationary position. Correct? Okay. With a uniform acceleration, attains a speed of 40 km per hour. Attains a speed of 40 km per hour. Then what is 40 km per hour? That will be the final velocity v, 40 km per hour. So if it is going at a uniform acceleration, it will attain 40 km per hour in 10 minutes. In 10 minutes. What is the 10 minutes? It is equal to 10. That is the time. That is minute. Now you can observe that we need to find out the acceleration, but the given quantities are in kilometer per hour and then minute. So these quantities I should convert into a meter per second, because acceleration will be this meter per second square. Then I need to substitute in the acceleration formula. Okay, then I should calculate. That's it. Okay, so we'll do that. Solution. Okay. Your initial velocity u is equal to 0 because it is starting from stationary position. Final velocity v, which is 40 km per hour. Convert into meter per second. How to convert into meter per second? 40 km into 1 km is equal to millimeter, 1000 meter. Correct? Divided by 1 hour. 1 hour is 3600 seconds. Okay. Now we cancel it. 2 0. Okay. Then we can able to cancel it by 4 because 9 you can cancel 36 by 4 and then you can cancel 40 also by 4. Then 4s are 4 9s are 36. Then 4 10s are 40. Okay. So what is remaining now? 10 into 10 in the numerator. In the denominator we have 9. Unit is meter per second. Okay. Now it is 10 into 10 into 100 by 9 meter per second. So divide 100 by 9. So how much you will be getting? 9 ones are 9. So 1 will be the remainder of the next digit. Then again 9 ones are 9. So 1 will be the remaining. Put the point 0. Again 9 ones are 9. Remainder 1. Now put the point 0. Okay. So 0. So again 9 ones are 9. Let's keep on going like this. So I will take after decimal point. I will take 2 digits. So what is that? So final velocity V is equal to 11.11 meter per second. So this is final velocity after converting it a meter per second. It is 40 km per hour. If you convert it to meter per second, that is 11.11 meter per second. Okay. Now we know the initial velocity and then final velocity, and we know the time taken also. Let me write the time taken. 11.11 meter per second, which is final velocity. Okay. Now we will write the time taken. Time taken T is equal to how much? 10 minute. Again it is in minute. So convert it into a second. So 10. So 1 minute is equal to how many seconds? 60 seconds, right? And this is second, right? So 10 into 60, 600 seconds. So time T is equal to how much? 600 seconds. Okay. Now use the formula of the acceleration. Acceleration A is equal to V minus U divided by T. Okay. So V is equal to 11.11 minus U is equal to 0 divided by 600. Okay. So 11.11 minus 0 will become 11.11 only divided by 600. Okay. So 11.11 divided by 600. If you want to remove the decimal point to here, you need to multiply with 100, both in the numerator and the denominator, right? So we'll let us multiply with the 100. So that is 11.11 into 100 divided by 600 into 100. So what will happen? So it will become 1111. In the denominator it is 600 into 1 will become 4 zeros. 60,000, correct? This is meter per second square. So can be able to cancel it. So if you can't able to cancel it, you can write minus. So this is the acceleration. Or if you want to simplify this, you can simplify this. Okay. So this is 10 minutes. 11.11. T is equal to 600 seconds. So you are multiplying with 100. Then you are getting 100. Denominator it is it is 60,000. Yeah, you can substitute. You can simplify up to here. Otherwise, if you want to divide it by 60,000, you will be getting in decimal points. But if you want to do it, you can do it for this. Okay. So like this, we need to do that. We will go for the next problem. So the next concept is graphical representation of motion. Graphical representation of motion. That means whatever the terms, whatever the physical quantities, whatever the concepts we have learned till now, that is distance, displacement, then velocity, speed, acceleration. So we have taken speed. How we have taken the speed? Speed is nothing but distance by time. Correct? Velocity we have taken as displacement by time. And then acceleration we have taken as rate of change of, that means rate of change of velocity, that is changing velocity divided by time, changing velocity. Okay, we are taking like this, right? So these things we have learned. So these physical quantities and these terms we can able to represent graphically. When it is represented graphically, we can able to obtain. If you know that speed, if you know that time, then you can able to find out the distance. Or if you know the distance and if you know the time, then you can able to represent you can able to obtain the speed. So whenever we are represented in terms of graphically, then it is very easy to find out. And how it is looks like, only by seeing the graph itself, we can say that whether the particular motion is a uniform motion or a non-uniform motion. So we can able to understand that, we can interpret from the graph. So whenever it is represented in terms of graphically, it is very easy to understand also, very easy to interpret also whenever we need the information. So we can able to interpret it, we can take it from the graph, right? So that's what we are representing the motion in terms of graphically. So in that first we are going to learn about distance time. Distance time graph. So distance time graph. That is distance versus time. We know that whenever we are represented in terms of graph analysis, it creates two quantity, right? So one will be the x-axis and another one will be the y-axis. So we need two quantities. Here, so the one quantity depends on the other quantity. You can see that distance is depends on the time. Distance depends on the time. Whenever the time changes, then only the distance will change. So distance is completely dependent on time. So here distance is dependent on time. It is a dependent quantity. Distance is a dependent. It is called as a dependent variable. So whenever we are represented in terms of graph, we need two variables, right? So we need to represent, we need the 2 points. So that point we will be plotting on the graph, and then we will be connecting those points. We will be getting a path. We will be getting a path in the graph. So that will be the representation of the particular motion, right? So here distance is one physical quantity and time is another quantity. So we need to see that how distance is changing with respect to the time. If time is changing, how the distance is changing. So we will be getting two quantities. So when you take those two quantities as a coordinates, if you plot the points on the graph, then if you join that, so that will be the representation of the particular distance time graph. So using that graph, we can able to obtain the data. We can able to interpret the data. That means by using that graph, we can able to find out the speed. So I will tell you how to find out the speed by using that graph. This has to be done by using the graph. Okay. So I will do the rough graph. You have to do it. We have an exercise for this. So now just understood how I am doing now. So I take a table. Suppose let us consider a situation. Okay, where time, this is time in second. Okay, this is distance in meters. Suppose the vehicle is moving. Okay, so we will be noting the time as well as the distance traveled. Okay, assume that we will be measuring the time and we will be measuring the distance also. So whenever the time is 0, the distance is also 0. second it will be traveling 4 meters. For the third second it will be traveling 6 meters. For the fourth second it will be traveling 8 meters. For the fifth second it will be traveling 10 meters. So suppose this is the situation. Okay, the car is moving in such a way that for the first for the 0, the distance is also 0. Distance is also 0. For 1 second it will be traveling 2 meters. For the next subsequent second it will be traveling 4. Next 6, next 8, next 10. So it is traveling like this. So by observing this table, we can able to say that the motion is what? Uniform motion or non-uniform motion? Definitely it is a uniform motion because it covers equal amount of distances in equal interval of time. So that what is the difference between these two? 2 minus 0, 0. 4 minus 2, 2. 6 minus 4, 2. 8 minus 6, 2. 8 minus 8, 8. Observe that. Same. Right? This is uniform. This is uniform motion. This is uniform motion. It will be changing equal intervals with equal amount of time. So here it is 1 second, 1 second, 1 second, 1 second. Difference is 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 1 second. For equal, it will be changing equal amounts in distances in equal amount of time. Okay. So therefore, this is a uniform motion. If I want to represent this situation graphically, how will I represent? So I will be taking a graph sheet. Okay. So this is x axis and this is y axis. This is origin 0 intersecting. So 1, 2, 3, 4, 5. This has to be equidistant. Similarly, this has to be equidistant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly, this is also be equidistant. Right? Okay. Now, let us take this as a time. Time t in second. And this as y-axis as a distance. Okay. So what is the first point? For 0, time is 0, distance is also 0. That means 0, 0, 0. Where we will be having 0, 0, that is x-axis also 0, y-axis also 0. This is the point. Correct? Now, the time will be 1 second, distance will be 2 meters. So 1, 2. Where is 1, 2? Time is 1, distance is 2. So this is right. For time is 2, distance is 4. Time is 2, distance is 4. So this point. Correct? So time is 3, distance is 6. So this one. So time is 4, distance is 8. So this point. Time is 4, distance is 8. So time is 5, distance is 10 meters. This point. Correct? So if you join all these points, so you can observe that you will be getting a straight line. You can observe that you will be getting a straight line. This is distance time graph if it is uniform motion. If it is uniform motion, I had told you in the exercise 1 or exercise 1, 2, what will be the path if the motion is uniform? So this will be the path. What is this? This is a straight line. Straight line which is passes through the origin. Right? So this is for uniform motion. This is for uniform motion. Now you can ask me, how will you get a speed by using this graph? How will you get a speed by using this graph? So manually we know that how to get the speed. Speed is equal to Distance divided by time, right? So what is the distance covered? Total distances, then total time taken. So what is the total distance we have? Add it, then what is the time taken? Add it, divide it, we will get the speed. So that will be the speed, right? Okay. So how to get it? By using this graph. Okay. So it's very easy. Do one thing. Okay. So to the path, whatever the path we have taken, from the x-axis, from any of the point, right here, perpendicular line like this. Okay. Then from that line, connect to the, this is 4, right? Okay. Similarly, from the another point also, like this, draw two perpendicular lines. Okay, so let me denote this as A, B. Okay, so now join these 2 points. So you will be getting a triangle, right? You will be getting a triangle. Okay, so what is this distance? BC. BC is nothing but a distance. BC is nothing but a distance. AC is nothing but a time. Now what is BC? BC is equal to, what is that? So BC, so this distance and this distance must be same, right? So what is the distance between these two points? This is 6 and this is 4. How to find out the distance between these 2 points? Subtract 6 minus 4, it will become 2. This is 2 meter. BC is 2 meter. Now, what is the distance between A and C? So that is same as this. That means to get the distance 4 minus 2. That means AC is equal to 4 minus 2. That is again 2. So this is 2 seconds. Okay. Now speed is equal to, what is that? What is distance? Distance by time. That means BC by BC. That means 2 meter divided by 2 seconds. So 2 can cancel, 1 meter per second. So speed is 1 meter per second. It is going at 1 meter per second. So like that we can able to find out the speed by using this graph. Not only speed, if speed is given, then we can able to find out the distance also. Not only distance, if distance also given, then we can able to find out the time. So that we can able to do it by using this graph. Okay. So we can able to write the graph for non-uniform motion also. Say like distance line graph. This is a uniform motion. This is uniform motion because it will be covering equal distance of equal interval of time. If it is a non-uniform motion, then it will cover say unequal distances in equal interval of time. Then again we will be taking time in one axis and distance in other axis. So then we will be plotting the points. Then we will join the points. Then that will be not become a straight line. That will be become some other shape, not like a straight line. Okay, we'll see that in the next class. That is distance time graph for the non-uniform motion. Then again we have velocity time graph for uniform motion, then as well as non-uniform motion. We will discuss that in the next video. So that's it for today's class. So we have a graph representation in the questions also. While discussing those questions, we will take the graph sheet and we will draw it. Okay. So thank you. That's it for today's class. If you have any doubts, please get back.